the product rule for differentiating is when you have two functions multiplied together. So in this case, for instance, we've got here f of x, y equals 5x times 6x plus 2 squared. So this is one function, we call that f of x, and the second function is a composite function itself, 6x plus 2 all squared. Now the rule is, my differential is f of x differential of g of x plus g of x multiplied by the differential of f of x, and that's it. Basically you just have to find out what each of these are and then work that out. So we know f of x is 5x, so f dash of x is 5. We know that g of x is this here, so g dash of x is going to be this 6x plus 2 squared differentiated, which is 12 6x plus 2. I'm not going to multiply that or tell you to do that, but you can use that by the chain rule yourself. So you're using the chain rule to get to this and then use your product rule. So the differential, or dy by dx, is equal to f of x g dash of h, which is 5x times 12 6x plus 2 plus g of x, f dash of x, sorry, g of x is that, f dash of x is 5 in this case, so 5 times 6x plus 2 squared. And so this is 60x, 6x plus 2 plus 5, 6x plus 2 squared. And that's it. It's fairly simple, not too difficult. I'll do another example. We have y equals x e of x. So in this case, f of x is x, g of x is the exponential function. So in this case, f dash of x is 1, g dash of x is e of x. Pardon me, and so I just put those back in. So I've got y equals, use my use my rule here. F of x is that, g of x is that, so that gives me x e of x plus g of x, which is that, f dash of that, which is e of x, times 1, which is just that, and I'm going to take a factor out there, so e of x, x plus 1. Okay, now the quotient rule, I'm going to do on the other side. The quotient rule is very much more complicated, and this is where we have y is one function divided by the other. Now the actual formula is in your formula booklet, but it's this. So g of x, f dash of x, we subtract this time, and it has to, so this time it has to be in the correct order, whereas the product rule doesn't have to be in the correct order, divided by g of x all squared. So I'm going to do an example, okay, and I'm going to do it one way and then have a go at it doing the other way. So this is 5x over e to the 2x. So in this case, f of x is 5x and g of x equals e to the 2x. So that gives me f dash of x. F dash of x is 5, and g dash of x, again, differentiate inside and outside, so 2e to the 2x. Okay, and so I just plug this into the formula. So y is g of x times f dash of x, which is 5e to the 2x. Take away these two multiplied together, so that's 2 times 5, which is 10x e to the 2x, all divided by e to the 2x squared. Okay, now if I look at up here, I've got factors here, so I can take a factor of 5 out and e to the 2x out, and that leaves me 1 minus 2x, and that's divided by e to the 2x squared. E to the 2x squared is e to the 2x times e to the 2x. I've got an e to the 2x here, so I can cancel those out, and so that gives me 5 1 minus 2x over e to the 2x. Now, I can, if I wanted to, rather than have use the quotient rule here, I can use the product rule. Okay, but this time, instead of using the product rule, I would write it y equals 5x multiplied by e to the minus 2x. Okay, because that's what 1 over is here. Now, if I do that, what I'm left with is the same as before. So this is now my f of x, and this is my g of x, but this time it's minus 2x. So f dash x is still 5. G dash x this time is minus 2e to the minus 2x. Okay, and so if I use my product rule, 5x times minus 2e to the minus 2x plus function up here, f dash of x of 5 times e to the minus 2x. Okay, well this is equal to minus 10x e to the minus 2x plus 5e to the minus 2x, which I can take a factor out, and I'm going to put this minus second. It gives me 5e to the minus 2x multiplied by 1 minus 2x. Okay, and as it is we did before, e to the minus 2x is 1 over, and so that is equal to 1 minus 2x over e to the minus 2x. Now, the quotient rule and the product rule, as you can see, are fairly similar. I personally prefer using the product rule, even if I get the quotient rule, because I find that it just looks too messy and not very pretty. But have a go at the exercises. The exercises are 4D. Have a go at them. Do the odd ones. 1 and 2 is normal, and the odd ones, yeah.